Now we know that matter is all around us. It's everything around us. As scientists, though, we want to be able to communicate with each other about what's around us in a common language. This is where describing the matter around us with its properties comes into play. All right, so let's switch our setup a little bit and dive into this lesson. I do recommend that you take notes through this lesson. This week's topic focuses on physical properties. We characterize the stuff around us. And by stuff, I really mean the matter around us. In terms of physical properties and chemical properties. We are going to start out focusing on the physical properties. By understanding how certain types of matter have certain properties, we can better understand the materials that we're working with. For example, let's say you want to make some pasta for lunch. So you fill up a pot with water, you put it on the stovetop, and you heat it up until the water boils, and then voila, you can make your pasta. You've already been thinking about the stuff around you in terms of these physical properties. You knew that if you put the pot of water on the stove, that you could cause the water to boil. So we can use these different values because different types of matter have different values for these properties, and we can compare and contrast these materials. Let's look at another example. Iron versus copper. How do you know which metal would be better for making nails or for making, wires in your electronics? Iron and copper, two different types of matter, different elements, have different physical properties that, make iron a stronger nail, but make copper better for making these flexible ductile wires. Let's explore these physical properties in a little bit more detail. Let's first define what a physical property is. So, physical property. This is a characteristic that can be measured or observed without changing the chemical composition of the substance. What I want you to do now is, thinking of this definition, look around where you are. Find an object and try to think of some of the physical properties, some of the physical characteristics that describe that object. So some examples that you might have thought of might include the color of what you were looking at, how much there was of the object, so that's its mass. Maybe you thought about its texture. Maybe you thought about its shape. So these are all examples of physical properties. Let's give a little more concrete of an example. Let's say you're sitting in your house and you looked and saw a rug on the floor. So let's imagine this rug. So its color, it's kind of, it's a little off gray. You might say like bluey kind of. It's pretty large. It looks like it's like maybe like a 5 by 8 foot rug. The texture, it looks very fluffy and soft. And the shape is that it's pretty, I'd say that's more rectangular, right? So we're observing this substance, we're observing this object, and we are characterizing it. But in all of our characterizations of this object, the object stayed itself. It's still there, it's still the rug, it still has all of those properties about it. All right, let's go through one more example. Maybe you're sitting and you look around and you see that you have a can of soda around you. Maybe you describe the soda itself, so it's a liquid, and a lot of these sodas are dark in color and they have a certain smell. Maybe you looked at the can itself. The can is actually made out of aluminum, and aluminum has certain physical properties. We can see the can is decorated on the outside with a certain color. It's a lot of these observations you're making about this object. I'm going to give you a list of common physical properties that we think about in chemistry. So, common physical properties. So that includes stuff like color, or texture, volume, and mass, the length of the object, the density, which we will get more into later on what density is and how to measure it. Also, things like the boiling point, like when water evaporates, turns to steam, or the melting point. So think of an ice cube melting here. Regardless of what this property is though, what we notice is that these properties do not chemically change the substance. So again, if I'm looking at that rug, me looking at that rug doesn't magically change the material it's made out of. Me watching an ice cube melt, it's still water. In comparison, and we're going to go over more of the chemical properties later, in comparison though, think of when you're at a campfire and you're burning the wood. Burning the wood actually changes the wood. But if we describe the physical properties of wood, we can say that the texture is rough, maybe it's brown or kind of orangey in color, maybe it's a 2x4 piece of lumber. Those physical properties, when we describe them, it's still a piece of wood. We're gaining this vocabulary of how to describe the matter around us. Let's discuss how we categorize these physical properties. All right, so get a new sheet of paper here. New title, physical properties can be described as, let me get a different color here. There we go. As intensive, oops, sorry, I keep moving the paper, or extensive. let's give these words some definitions so they make a little bit more sense. So if a property is intensive, that means it is a characteristic that does not depend on the amount of matter. So how much of the object or substance you have. Conversely, an extensive property is one where the characteristics do depend on the amount of matter, so how much of that substance you have. Let's work through an example to see the differences in these types of characteristics. And our first example is actually going to be one of my dogs. Let's look at Jasper. He's a pretty big dog, and he's the one with only one eye. So look at this photo for a second and think about how you would describe Jasper using physical characteristics. Look back at that list we just made. Try to describe some of those characteristics. Think about which of those characteristics depend on how much of him there is. Let's dissect that example. Draw a line. So our example was the adorableness of Jasper. Well, the adorable dog Jasper. What you might have noticed was that his fur, the color of his fur was like tannish, kind of orangey. There were some white spots, white places. You might have said that the texture of his fur was quite fluffy. These two properties, the color and texture of his fur, it wouldn't matter how big or small he was. His fur was that color, and it's just always fluffy fur. So it did not depend on how much of Jasper there was. That means that these properties are intensive. Again, it wouldn't matter if he was small or big. Those properties are those properties. You might have also looked at him and said, he is quite big. And he takes up a lot of space. What you're describing here is his mass and his volume. However, these two properties, mass and volume, depend on how much stuff of that object you have. If he were even bigger, he would have an even bigger mass and an even bigger volume. If he was smaller, he'd have a smaller mass and a smaller volume. So these do depend on how much Jasper there was. That means that physical properties like mass and volume are extensive. Let's make a list of those common physical properties and categorize them as being intensive or extensive. So I'm going to make one column for intensive properties, one column for extensive properties. And let's make that list. Intensive properties, so they do not depend on how much you have, include things like color, melting point, boiling point, and density. So we're talking more in terms of properties for chemicals that we would talk about. I'm not going to melt my dog and find his melting point. For extensive properties, these depend on how much you have. This includes things like mass and volume and length and even shape. Sometimes the more you have can change the shape of something. Why is it important for us to understand the differences between intensive and extensive properties? Well, firstly, it allows us to think critically about the matter, the chemicals we're working with. Think about if you have an unknown material. You could go through these lists and identify what is unique to that material and hopefully figure out what it is. Speaking in terms of chemistry, here is a chart of physical properties of some substances. And we're going to get more into the elemental chemical analysis later. But I want you to see here is that different substances have different values for these properties. So for example, water at room temperature is going to be liquid, it's colorless, and it has these specific melting points, so when an ice cube melts, and boiling points, so when it turns to steam, and these are in Celsius. Different substances, different elements have different characteristics. So again, this is how we're able to say, yes, an iron nail is much sturdier than a copper nail, but a copper makes better wires. Let's switch gears a little bit. I want to talk about something that is super important for you as a scientist, as a thinker, as a person in this modern world. What I mean by that is that every day we are using our senses to observe the world around us. And we just talked about how we can really go nitty-gritty in detail for physical properties. But how we actually take that measurement, how we observe that property is really important. So there are two main ways that we can observe and measure these properties. And that is qualitatively versus quantitatively. So I'm going to write that now. So we have a qualitative property versus a quantitative property. So you're noticing a trend here. First, we're going to define what these words mean. So qualitative. This means that the property, the physical property, is being observed. You could probably guess that qualitative sounds like quality. And these are characteristics that we describe more through our kind of senses. So, that rug we looked at earlier was a gray color. That's a qualitative, observed characteristic. Quantitative on the other hand means that we are directly measuring a value. So this property is measured. And also, as you can imagine, quantitative sounds like quantity. So how much of something we have. An example of this is the boiling point of water. We measure that actual temperature. What I want you to do now is think of the object you looked at earlier. I want to give you a list of common physical properties and if they are more qualitative or quantitative in nature. So common physical properties, and we have qualitative, versus quantitative. Nice little table. Ooh, I did not draw a straight line. All right, some qualitative, that's a bad line. Some qualitative properties include color, odor, how it smells, taste, texture, luster. So think of certain metals are like shinier than others, right? Also viscosity. So we're gonna get more into this later, but viscosity is actually a pretty darn cool property. So it deals with how thick something is. So think of honey versus liquid water. We're gonna get more into that later. Also think about malleability. Malleability. So an example here is that copper wire, right? You can easily bend it to how you need it. Some common quantitative physical properties include mass, length, density, which again we'll get into later, boiling point, melting point, and solubility, which we'll also get into later. So for solubility, think of dissolving sugar into water. There's only so much you can actually dissolve, right? All of these quantitative properties you can measure with an instrument. A ruler, a balance, a thermometer, all of these are quantitative. You can actually take a direct measurement. Qualitative, like color, odor, taste, these can be a little trickier because maybe I think that this tastes, more bitter than you do. So we're going to discuss this more in depth in a class period, but can you think of why using one type or the other, qualitative or quantitative, might be more useful in a situation, and why? We now have some really good chemistry vocabulary in our toolbox to analyze the world around us. But the world around us is not static. The materials you can see around you don't always stay exactly how they are. Changes happen. And specifically, we can describe those changes as physical changes or chemical changes. Today, we will be focusing on physical changes. As always, let's define what this actually means in terms of chemistry. So, physical changes. This is when you do something to matter, so to the stuff around you, that changes its state, which we'll talk more about later, or properties. But it does not change its chemical composition. Okay, so right here, we're looking at a GIF of some ice cubes melting. So the ice cubes are heating up and they're going from solid to liquid. So you can think of Olaf, right? So like everyone's always afraid that he's gonna melt. Think about if you are filling up an ice cube tray with water and you're about to freeze this water into ice cubes. At the end of the day, through all of these changes, right? So even if Olaf melts, it's all still water, right? Like we know that ice cubes are water. We know that water in a cup is liquid water. We know that steam is gas. Water is a gas. At the end of the day, though, it's all still water. Let's look at another example. Let's say you're driving and unfortunately, a rock hits your windshield and your glass windshield breaks. Well, first, I hope that you're safe. But think about your windshield. Did it change into like another type of matter? Is it still glass? Is that still your windshield? Yeah, it still is. It just got basically chopped into smaller pieces. So this is also an example of a physical change. Let's look at another. So we have sugar on the left and salt on the right. Let's say you're, making some recipe and you accidentally get them confused and you mix the sugar and the salt together. When you look at that pile of sugar mixed with salt, what is it? Is it some new type of substance? Is it some new type of matter? No, it's just sugar and salt that have been mixed together. And if you had the time, you could very slowly separate them back out into sugar and salt. Another example of physical change. So that's actually me chopping wood. It's actually kind of fun. So let's say you're splitting wood, you're chopping wood. This is a physical change because before you chop it and after you chop it, you still have wood. Maybe the mass changes, maybe you're working with smaller pieces of wood, maybe the volume changes. Again, you go from big to small. But at the end of the day, it's still wood. Let's think of crushing a soda can. So, you have that soda can, you squish it. Is it still made of aluminum? Is it still a can? Did it magically turn into something else? No, you crushed it. For all of those examples, what I want you to notice is that, again, you're doing something to the matter. You're chopping it, you're splitting it, you're mixing it. But at the end of the day, you're not changing what the actual substance is. Something I want to point out is that in all of these examples, we have looked at the properties, largely the properties of it, right? So the wood, it's still the coarse texture of wood. Glass, your glass windshield, it's still, that see-through solid. What about state, though? I want to explore that briefly. We're just going to do a little introduction to states right now. So, state changes are physical changes. The three main states of matter are, I'm going to draw a triangle here, okay? Solid, liquid, and gas. And we can go between these states, among these states. For example, think of water. So we can think of water in terms of ice as a solid, liquid water, which we just call water, and a gas, like steam. At the end of the day, if that cup of water you started with went from water to ice, back to water to steam, it's still water. It didn't change into some other magical substance. So the matter is still the same matter. And what we're going to get into is what actually makes them different states of matter. We'll get more into that later. For right now, I just want you to know that state changes are physical changes. And that means that when you change it, solid, liquid, gas, it's still the same substance. Great. Now we have the vocabulary to describe objects physically. And what we're going to get into next time is describing objects chemically. So chemical properties, chemical changes. And I want us to think about why having these different types of properties are important. So as always, if you have questions, reach out. And I hope that you can start looking at the world around you in a little bit of a different way.